This is part one of solving trig equations. It's going to end up being kind of a long video, so just remember to go at your own pace. You can pause, rewind, fast forward, whatever you need to do. So first off, when I say trig equation, what I mean is just any equation that has a trig function in it. So if you have an equation that has sine x in it, or tangent theta, anything like that, that's what we call a trig equation. Now eventually, to solve them, you're going to end up using inverse trig. But there's a little bit of work before that. So let's start off, before we talk about the actual solving, let's talk about the answers themselves, or the solutions to the question. And that's important because we want to recognize that every trig equation is going to end up having infinitely many solutions. So here's a quick example to show you why. Let's start off with a very simple equation, just cosine x equals 1/2. If you use inverse trig in the unit circle, you're going to get two answers. You're going to get pi over 3 and 5 pi over 3. But then you think to yourself, okay, well, we learned about coterminal angles. If I add 2 pi to any of those answers, like for example, pi over 3 plus 2 pi gives me 7 pi over 3. Or 5 pi over 3 plus 2 pi gives me 11 pi over 3. And I'm going to just put a dot, dot, dot in there because anytime I add or subtract 2 pi, I'm ending up with the same spot. That's also going to be an answer. So we want to have a way to represent the infinitely many solutions using patterns. To do that, we're either going to use this plus 2k pi notation or possibly just a k pi. So basically, when I say plus 2k pi, k stands for any integer or any whole number, positive or negative. And what that means is, basically, it's a way of saying anytime I add or subtract 2 pi, I'm getting another answer. So it's going to cover all of your answers that are repeats outside of the unit circle. So basically, if you go back to our example, cosine x equals 1/2, if I take my two answers from the unit circle, pi over 3 and 5 pi over 3, and I just put that plus 2k pi on the end, that means my answers are pi over 3 plus any full rotation, or 5 pi over 3 plus any full rotation. And that covers all solutions. Now, tangent and cotangent are a little bit different, and I said in the notes they're actually a little easier, because tangent and cotangent actually repeat twice every time around the unit circle. So what you have to do, instead of listing both answers and putting plus 2k pi on each one of them, you just list one of the answers and you use k pi instead of 2k pi. So basically what you're saying is you take that first answer, if you add 1 pi, it goes halfway around the circle, you find the other one. Add 1 pi again, it goes halfway around back to the first one. So you're going half circles around to find your answer, and you're still getting all the repeats. All right, so the first thing you're going to do when you're solving a trig equation is you're going to look at the directions and figure out which answers you're supposed to give. So here are the possible answer sets. You might be asked to find, number 1 is the one I just went over with you guys. If you're asked to find all solutions, that's when you, number 1, use the unit circle first. And then number 2, you're going to use that 2k pi. I actually wrote 2n pi in the notes. Some books use 2n pi, and I wanted to show you both. But you're going to use plus 2k pi or possibly 2n pi. Or, and then I said if it's degrees instead of radians, you might need to use 360k or n in that case. You also might need to use just k pi for tangent or cotangent. Okay, now the second thing that you might ask you to find is certain questions may only want the answers from the unit circle. So it may say, find all solutions, x is between 0 and 2 pi. That's telling you, number 1, to use radians because it said 2 pi. And number 2, to not worry about the plus 2k pi. Just give the answers from the unit circle and stop. Also, it might say, give me answers, x is between 0 and 360 degrees. Again, it's saying, just do the unit circle and stop, but this case, it's also telling you to answer in degrees. The last one, this is actually pretty unusual, but you might get a question that just asks you to answer on a different interval. So I said in the notes, maybe the question says, give me answers between 0 and 180 degrees. And that means answer in degrees, but only from the top of the unit circle. Or if it said, between 0 and 90. Give me the answers only from the first quadrant, that kind of thing. Now the one thing I want to mention, if the question just says solve for x, period, with no extra directions, then number 1, it definitely means find all solutions. And we're going to say, let's just answer in radians. That's the more common way to do it. All right, so here are the steps to actually solve. We had a lot of setup just about the answers themselves. When it gets to the solving, step 1 to solving a trig equation is to isolate the trig function, that sine x or that tangent theta, whatever it is. Get it all by itself. Then step 2 is the inverse trig. That's the unit circle part. Then step 3 is what we just talked about. Make sure you're giving the right answer. Am I only giving the answer from the unit circle, or am I using the plus 2k pi? Am I giving my answer in degrees or radians? That kind of thing. So here's our first example for today. We are going to solve for x. Cosecant x plus 2 equals 0. And notice I didn't give any extra directions. So what we said is, number 1, we're giving all solutions. And number 2, we're going to go ahead and use radians. But before we get to that part, let's do the actual solving. So step 1 is isolate. In order to isolate for this one, I would need to subtract 2 from each side. So I'm going to have cosecant x equals -2. Now I've isolated my trig function, but it's one of our reciprocal functions, and I don't like working with those. So I'm going to flip it. I'm going to say if cosecant x is -2, then its reciprocal, sine x, is -1/2. That's much easier to answer using the unit circle. So step 2, use the unit circle to answer the question. And we're doing radians, remember. So the two places where sine equals -1/2 would be 7 pi over 6 and 11 pi over 6. And step 3 was just make sure you're giving the right answer. And since I didn't give directions, we're giving all solutions. So what I want to do for my final answer is I'm going to take each answer and just stick that plus 2k pi on the end to mean anytime I add or subtract, because k can be a negative number too, anytime I add or subtract 2 pi to either one of those things, it will also give me an answer. Okay, let's try another example. So this time we are solving 2 sine squared x minus 1 equals 0. And this time we're doing it on the interval 0 to 360. So that tells me two things. Number 1, answer in degrees. And number 2, don't worry about repeats. Just give me the answers from the unit circle and stop. Only answers between 0 and 360. That's where the unit circle starts and stops. Now, as far as isolating for this one, I'm going to start by adding 1 to both sides. And I get 2 sine squared x equals 1. The next thing I want to do is divide that 2 out of there to cancel that. And I get sine squared x equals 1/2. Now, the last thing I want to do is I want to cancel out that squared by taking square roots of both sides. So what I get, I have actually isolated now. I got sine x. Now make sure you remember your plus or minus here. So you have plus or minus, and I'll leave it as square root of 1/2 right now. Now the square root of 1/2, if you square root the top and bottom separately, you get 1 over radical 2. And you think, okay, well it doesn't look like a unit circle question, but it actually is, because if you rationalize that, if you multiply the top and bottom by the square root of 2, what we're actually ending up here, and remember we still have our plus or minus there, you're ending up with radical 2 over 2. So what we're going to end up with for our final answer here, we're going to have 4 answers here. Because of the plus or minus, we have 2 answers where where sine x equals positive, radical 2 over 2, and 2 more where it equals negative, radical 2 over 2. So what I'm going to get is I will have 45 and 135. Those are the 2 places where sine x equals positive, radical 2 over 2. But then I will also have 225 and 315. So I end up with 4 answers for this one. Okay, I want to do one more example with you guys. And what we have here is something called a multiple angle problem, because it's not just tangent x, it's tangent 3x. That's what we mean when we say multiple angle. The x has been multiplied by some number. So what I'm going to do here, I'm going to go off to the side, and I'm going to say, let's pretend like this question was just tangent x equals 1. Then I would say, okay, from the unit circle, there are actually two, but remember for tangent and cotangent, you only have to worry about one of them. So we'll find one. The one place, or one of the places, on the unit circle is pi over 4, because that's where sine and cosine are both the same. They're both radical 2 over 2, and if you put one over the other, it ends up being 1. So then, since there are no directions, I would say I want all solutions, so I add my plus k pi on the end, and I would be done. Now what I want you to notice here is that this angle x is the angle that you are solving for. That's what goes right here. So if you go back to your original question, we're going to solve it the exact same way, but we're going to be solving for 3x instead of x. Because again, this angle here is what goes here. It's what you're solving for. But then the question is the same. You're still asking yourself, where on the unit circle does tangent equal 1? And that would be pi over 4. And then, because we're doing all solutions, you would do your plus k pi. Now here's the thing, we're not done. We've solved for 3x, but I asked you to solve for x. So to finish this question, what we need to do is divide everything by 3 to cancel that out. So my final answer, pi over 4 divided by 3 would actually end up being pi over 12. And then the k pi over 3 doesn't reduce, so I'm just going to leave it. Now this right here is my final answer. So that's called a multiple angle question. Remember, if you ever have inside of your trig function tangent of 3x or sine of 2 theta or something like that, solve the question normally, but you get an extra step on the end where you have to finish solving for x.